All right, let's talk about something that's super important for anyone managing SAP HANA. But let's be honest, it can get a little confusing. I'm talking about data at rest encryption. We're going to break down exactly how it works, get to know the different keys involved, and figure out how you can manage them like a pro. So yeah, let's just dive right in.
Okay, so right off the bat, let's tackle the one big question that seems to trip everybody up. Why on earth does SAP HANA use two different kinds of encryption keys? I mean, wouldn't one be simpler? Well, there's a really good reason for this so-called complexity. It all comes down to a delicate balancing act between top-notch security and blazing fast performance.
And to make this whole thing super easy to wrap your head around, we're going to use a simple analogy for this whole explainer. Just think of a bank vault. Seriously, once you picture it like that, this whole two-key system is going to click and make a lot more sense. All right, let's meet the main players here. We're talking about master keys and page keys. See, SAP HANA's encryption for data sitting on the disk, data at rest, is built on this two-key system. And really, getting what each one does is the absolute first step to getting a handle on all this. So here's the nuts and bolts of how it works. When your data moves from memory and gets written to the disk, that's our data at rest, it's not just one big blob. Individual pages of data get encrypted by something called page keys. Using our bank analogy, think of these page keys as the individual keys to every single safe deposit box inside the vault. Makes sense, right? But wait, what protects all of those keys? Well, that's where the root key comes in. It's the one master key that locks the main vault door itself. And here's a really important point for performance. While the data is in memory, it's actually unencrypted. The encryption only kicks in the moment it hits the disk. Okay, so we've got the basic idea down. Now let's zoom in a little closer and really compare these two types of keys, because they do very different things and live very different lives, so to speak. This chart really lays it all out perfectly. Let's look at root key rotation. Who does it? You do, the administrator. It's a manual thing, usually for security compliance, right? It's like changing the master lock on the main vault door once a year. Now, page key rotation, that's totally different. The HANA system handles that all by itself, automatically. And what's being changed? With the root key, you're changing that one master key. With page keys, the system is changing the many individual keys for the data pages. And the impact? This is huge. Rotating the root key has zero impact on the data itself. But when page keys rotate, the data pages are actually re-encrypted over time. It's all about good security hygiene. So here's the bottom line, the thing you really need to remember. When your security team comes knocking and says, hey, it's time to rotate the master encryption key, you don't need to panic. It is not some scary, downtime-inducing event. Because all HANA has to do is re-encrypt the other keys. Not all your terabytes of data. The whole thing is super fast and happens while the database is completely online. Okay, so we're all on the same page. The root key is basically the key to the entire kingdom. So that leads to a pretty obvious question, right? Where in the world is this super duper important key actually kept? Well, SAP gives you three main options here, and you can kind of think of them as good, better, and best. The default, out-of-the-box standard is something called SSFS, the secure store in the file system. Then you've got the more secure enhanced standard, which is LSS, or local secure store. And finally, for the highest level of protection, you can go with an external KMS, or key management system. So, the default setup, SFFS, what is that exactly? Well, your root key is stored in two little files right there on the server's operating system. You've got a .dot file and a .key file. Think of the .dot file as a little safe holding the key, and the .key file, well, that's the key to open that safe. The security for this whole setup boils down to your OS file permissions, and you can probably see the potential issue here, right? If someone, an attacker, or even a rogue admin, gets access to the HANA OS user, they could just copy those two files. And if they do that, they could potentially compromise your entire encrypted database. Yeah, not great. Now, the LSS, or Local Secure Store, is a huge improvement. What it does is it takes the key management stuff and puts it into its own separate service. And this is the key part, that service runs as a different OS user. This creates what we call a separation of duties. It means that even your database administrator can't just go in and grab the key files. This adds a really crucial layer of security, protecting you against that very risk we just talked about. And then we have the top tier, an external KMS. For any organization with really strict compliance rules, this is the gold standard. With a KMS, the master key isn't even on the database server. Nope, it's stored completely off server in a dedicated hardened appliance. So every single time your HANA system starts up, it has to reach out and authenticate with this external system just to get the key. This gives you amazing centralized control and, really, the highest level of security you can get.
All right, so we know what the keys are, we know where they can live. Now let's get practical. How do you actually go about changing that master lock? Let's walk through the root key rotation process.
And I just want to say this again because it's so important. Don't be scared of this process. SAP designed it to be totally safe. It's a non-disruptive online procedure. You can do this critical security task with complete confidence, knowing that it requires absolutely zero downtime for your system. The whole thing breaks down into 5 pretty clear steps. First up, you set a password for the key backup you're about to make. Simple. Step 2, you tell HANA to create a new root key, but, and this is important, you tell it not to activate it just yet. It's just sitting there, pending. Then comes step 3, the really critical one. You pop over to the operating system level and run a command to back up your root keys. This backup now contains your old active key and your new pending key. Only after you know that backup is safe and sound do you move to step 4, activating the new key. And finally, for step 5, it's always a good idea to run that backup command one more time just to be safe.
You know, I really want to pause and hammer this point home. The official documentation couldn't be clearer about this. Backing up the key store before you activate the new key is, without a doubt, the single most critical step in this whole procedure. Why? Because it guarantees that if anything goes sideways, you have a secure copy of both the old and the new keys, and you can always recover.
Okay, we've talked about what the keys are, where to keep them, and how to change them. But what if you're starting from scratch? What about turning on encryption for the very first time? Let's cover that final piece of the puzzle. And the great news is, it's super easy. Seriously, whether you're a command line person or you prefer the nice GUI of the SAP HANA Cockpit, it's literally one command or the flick of a switch. You just turn it on and the system starts quietly encrypting everything in the background. Okay, but here is a super important heads up, a critical piece of advice. If your HANA system uses system replication, for high availability or disaster recovery, you have to break that replication link before you turn on encryption. Once encryption is on and running on your primary site, then you can set up the replication again. The system will then sync everything over to the secondary, including the encrypted data and the keys. All right, let's just quickly recap the big points we've covered. First, HANA's two-key system is all about balancing security and performance. Second, changing the master root key is a manual, fast, and online job for you, the admin. But the page keys, they get rotated automatically by the system. Third, you've got those 3 tiers for storing your root key: the default SSFS, the better LSS, and the best-in-class external KMS. And finally, turning on encryption is simple, but you gotta plan carefully, especially if you have system replication in the mix. And that really brings us to the final and maybe most important question. Look, changing your keys regularly is great security hygiene, for sure, but it forces you to ask a much bigger question about your own setup. Are your keys, the most valuable secrets in your entire database, really being stored in the most secure place they can be? Because while the default setup is okay, migrating away from that file-based storage and over to an external key management system, well, that's the ultimate move to truly lock down your data at rest. It gives you that real separation of duties, that centralized control, and really the highest possible confidence that your data is safe from, well, everyone.